6 a.m. here where I'm working. So great to be able to start early in the morning here. I'm a programmer, a publisher, a software process engineer. My practice area is in helping organizations understand things in terms of systems and understand systems in terms of services. So I've always been a bit perplexed about the disconnect between how software teams are funded and how the feedback we provide as stewards of those resources. And I've had some insights into the question of productivity metrics, and I wanted to share some reflections about that with you here today. So thanks a whole lot for taking time out of your day to come here and hear my little report, and I hope that my observations are in some way useful. So when you bring up the topic of feedback in the Agile community, people seem to think along the lines of the kind of thing that happens in a retrospective session. The kind of information that we gather in this way is valuable and important, and it's certainly an improvement over the kind of insensitivity that was the norm in pre-Agile IT departments. But there are other kinds of feedback as well. The profit and loss statement, for example. The P&L seems to be considered a bit of a relic in the age of Agile, but it stood the test of time as a valuable feedback mechanism, especially when avoiding bankruptcy is one of your KPIs. Something about enterprise digital transformation initiatives has always struck me as odd, with everyone looking much like they did before, but acting in ways inconsistent with their former decorum. I gained some insight into this dynamic through the story of Phineas Guage, retold by Tim Harford in his book, Adapt. About 20 years before the American Civil War, Phineas was blasting rock for the Rutland and Burlington Railroad, just south of Cavendish, Vermont. Phineas was tamping down blasting powder in a rock bore when his metal tamping rod generated a spark, which ignited the explosive dust. At the moment when the gunpowder ignited, the gregarious Mr. Guage was just turning to talk to his crew behind him, bringing his head inadvertently in line with the trajectory upon which the rod was about to embark. The steel tamping rod was over 20 millimeters in diameter and just over a meter in length, weighing about 6 kilos. The explosion in the rock bore turned the steel rod into a projectile, which entered Phineas's open mouth, passed behind his left eye, clear through the left frontal lobe of his brain, exiting the top of his skull with force, crashing down like an artillery shell some 25 meters distant. The unfortunate Mr. Guage had the remarkable fortune not only to survive, but remain conscious through the ordeal and was able to explain the circumstances of the accident to the attending physician a half hour later, while the good doctor stared at disbelief at the gaping hole in the man's skull. Although the steel rod carried off a not entirely insignificant portion of Phineas's brain, he recovered and he went back to work, although not for the railroad. He traveled to Chile and took a job as a stagecoach driver on the Valparaiso-Santiago line, evidence that he continued in life as more than just an invalid. Other than being blind in his left eye, he looked like the same man as before. But there was some distinctive change in behavior. Before he had been known as a reasonable man, but Phineas, missing a decent-sized chunk of his brain, was often belligerent and indifferent to social norms that he had previously respected. In short, while he retained nearly all of the abilities of his former self, he seemed to have lost much of his ability to process feedback. When an enterprise embarks on a digital transformation initiative, it seems as if a steel rod has been blasted through the corporate cranium, taking out the part of the brain that processes feedback about profit and loss while leaving everything else intact. Whereas before we knew vigilant guardians of the balance sheet, we find purveyors of retrospective narrative, turtles all the way down. If an agile transformation is going to improve our ability to deliver value to the business, then we should be able to tell the story of that value in the P&L. And I get it that the legacy profit and loss statement structure represents challenges in attributing costs and revenues in complex dynamic scenarios where software engineering teams ply their trade. And I understand that it's not an easy problem, but papering over the misalignment between agile initiatives and the P&L is a lot like Phineas with the feedback part of his brain. Without the feedback part of his brain, you can count on him showing up to work, but you might wonder what he's capable of next. I think that some of the most important work before us today is to strip away the apparent complexity around what we mean by productivity, including how to measure it, and to put those metrics in alignment from the pull request edge all the way through to the P&L. Now, the balance sheet and therefore budgets are typically organized in terms of cost centers, but the activity of building, delivering, and supporting software systems tends to cut across those cost centers. And agile frameworks tend to favor self-referential, team-focused metrics, which serve to justify budget allocation, but there's not any way to connect them up to the cost-centered accounting. They're like two separate worlds. When we ask about this problem, it's like asking the old farmer for directions to a town he's never heard of. And he thinks about it and he says, well, son, you can't get there from here. Well, I think we can get there in our case. The solution to our problem, or at least the general direction of a solution, is not so mysterious. Knowledge work activities such as software need to be conceived of as systems and organized and implemented and accounted in terms of services. Fortunately, service orientation is in the DNA of Kanban, and if you're following the KMM, the Kanban maturity model, it's already on your roadmap, so you don't have to become an expert on management and budgeting to know that you're on the right path. Just start from where you are and be careful to lay a solid foundation. The important thing is not to overreach into practices that you're not ready for. And that gets to the essential problem I had in preparing this talk, is really when it comes down to it, there are very few agile coaching engagements today that are with organizations that are ready for this kind of discussion. They need it, but they're not ready for it. To put it in terms of the KMM, we need the role of service delivery manager to be well developed. And that puts us at something like maturity level 3 or 4. If you have teams that don't even have consistent delivery practices, then all of the budget alignment mumbo jumbo talk is going to be more like trying to coach couch potatoes for the Ironman marathon. So instead of waxing eloquent about things that you might try with clients that you don't have, I wanted to try to use this time to figure out how to light a fire under your own engineering couch potatoes to bring home the relevancy of feedback in the here and now. So how many of you have been to this place here? Beautiful. A few years ago, I had the opportunity to visit Japan, and like any tourist, I visited a number of shrines, as many as I could get to. I also had the opportunity to visit the Toyoda Museum in Nagoya, which is a sort of shrine to lean practice. The curators went beyond creating a mere showcase of inventions to tell the story of innovation as a process. In 19th century Japan, when manually operated wooden shuttlecock looms were the cornerstone of the local economy, Sakashi Toyoda was an unusually observant child who grew up in a village of weavers. He watched the workflow of the weaver and the loom. His parents surely thought that there was something wrong with the quiet concentration of the young child, but observation became innovation as one day he showed how to reconfigure the loom so that it can be operated with just one hand, resulting in a significant improvement to productivity. Sakashi Toyoda obtained his first patent in 1890, and in the following years, he iterated relentlessly, including plans for the first automatic shuttle change loom in 1903, one in a long and prodigious series of advancements that competitors sought to copy. When his colleagues asked what to do about the patent violations, Toyoda famously said, "The thieves may be able to follow the design plans and produce a loom, but we are modifying and improving our looms every day. They do not have the expertise gained from the failures it took to produce the original. We need not be concerned. We need only continue as always, making our improvements." In the decades that followed, the Toyota automated loom company became a prosperous enterprise. With Ford Motor Cars transforming the economics of transportation, Sakashi Toyoda set his sights on auto manufacturing, a much more ambitious undertaking. He sent his son Kiichiro abroad to sell their portfolio of loom patents, closing a deal with the Platt brothers in the United Kingdom for their automatic loom, raising capital for an automotive startup in an industry already dominated by American and European manufacturers. Despite extensive metal casting experience that they brought to their project, the defect rate of their early engine blocks was very high, and the success of the venture was in no way a sure thing. So one can imagine these guys in their workshop in Nagoya burning through their capital, surrounded by ruined engine blocks, wondering if they should have just stayed in the loom business. Well, they did go on to produce a few good cars. Toyota produced trucks through the war years, but the post-war years were bleak, with no money to retool for car production and nothing but a small, fragmented market. During the post-war period of rebuilding, there was a line manager from the Toyota automatic loom company named Taichi Ono, who transferred into Toyota Motors as a shop supervisor. He had been a careful student of Ford system and Taylorism, and when he had the responsibility to set up production lines himself, he was forced by adversity to make a number of critical innovations to what was considered manufacturing best practice at the time, including just-in-time delivery, which introduced a new paradigm, which eventually became a model for software delivery practices today. To understand the significance of Taichi Ono's contribution, we need to take a step back and look at the thinking that he departed from. The assembly line manufacturing process pioneered by Ford, based on something called the theory of scientific management, promulgated by efficiency expert Frederick Winslow Taylor, a contemporary of Sakashi Toyoda. From the days of the Ford Model T, American auto workers were trained to do just one task and to do it in the least time possible. They weren't being paid to think, and management made sure they knew it. Efficiency experts trained in Taylor's system would study each step in an assembly process, such as attaching some part with bolts, and prescribe where the bolts in the part should be at the start of the operation, which bolt to put in first, which last, how many turns of this wrench were required to tighten each bolt, and the total time of the operation. That time was then built into the physical assembly line so that it was entirely non-negotiable with the worker. No nose scratching or pee breaks permitted. Either do the work in the prescribed time or we'll find somebody that can. Lest there be any doubt about Taylor's outlook, he declared that, quote, "Hardly a competent workman can be found who does not devote a considerable amount of time to studying just how slowly he can work and still convince his employer that he is going at a good pace." Nice guy. Taylor's story is a little more complex than all of that, but it gives you the sense of it, and you can contrast that with the outlook of Sakashi Toyoda. Taylor's system of efficiency succeeded in crushing the competition from handcraft assembly of machines, and within a generation, the Ford Motor Company style of assembly lines was in widespread use globally, with the economic benefits being quickly normalized. The collateral damage to the workforce resulting by continued strict adherence to Taylor's management methods were counterproductive, but fixed time as a measure of efficiency continued to be the standard of practice long after it had outlived its usefulness. By the 1970s, the long shadow of Taylorism cast over American manufacturers was a big factor contributing to poor quality and adversarial labor relations that brought American car manufacturers to the brink of bankruptcy. The process pioneered by Taichi Ono at Toyota was eventually championed in the West by W. Edwards Deming, who was brought to Japan as a statistician to work on the census for the Occupation Authority. Deming only became a consultant to manufacturers through friendships he made with Japanese business leaders during the Reconstruction period. The humble census official was invited to speak at a luncheon, and they got on like a house on fire. The rest is just history. Trained as a physicist, the self-made statistician and management consultant was an all-around great guy. Deming was perhaps the most outstanding catalyst for the science of productivity of the 20th century, merging the culture of Toyota with the American tradition of invention and innovation. Deming hardened the science of innovation with the discipline of statistical analysis. The core of what Deming taught in Japan he attributed to the quality control pioneer from Bell Labs, his colleague Walter A. Shewhart. Shewhart taught the concept of how to bring a process into statistical control, and then to manage quality as a matter of continuous improvement rather than adherence to specification. Now, those of you familiar with the Toyota production system principle of Kaizen will recognize its roots in Shewhart's statistical process control. Taylorism was built around the idea of cost accounting, and that, combined with the innovation of the assembly line manufacturing, led to economy of scale as the holy grail of manufacturers. The sheer scale of General Motors made them an overwhelming competitor. Toyota of the 1950s and the 1960s didn't have access to a market to sell at scale, even if they could manage to produce. They had to produce what they could sell, which meant small numbers of a great number of car models. The genius of Taiichi Ohno was in adapting the process to embrace this variability. Now, early Japanese auto imports to the US were cheap and low quality, but the fusion of Deming, Taiichi Ohno, and other contributors produced what became known as the Toyota production system, under which quality improved relentlessly. Now, Americans have pride in nothing so much as their cars, and they responded to the Japanese insult of better and cheaper cars in the true spirit of the free market by imposing import tariffs on Japanese cars to make them more expensive. This forced Toyota into a joint venture with GM. The first attempt to run the Toyota production system in the US was in 1984 as the Toyota GM joint venture called NUMI, the New United Motor Manufacturing Incorporated, at the Shutter GM factory in Fremont, California, the location of what is now Tesla Motors, a very storied factory. The plant had the highest defect rate of any GM plant in the 1970s, and that's saying a lot. They were producing the Chevy Celebrity and the Olds Cutlass Sierra. Nice cars, other than how frequently they were in the shop for repairs. GM had spent a decade fighting with the United Auto Workers before they could finally get out of their contract with the union at Fremont. So when Toyota insisted on retaining the same workforce for their joint venture, the GM executives thought the Japanese were simply naive, warning the incoming Toyota team that they simply didn't understand how bad these American union workers were. The part that the GM guys didn't get, that the Toyota executives understood, was what Deming and Shewhart had taught. That quality is almost always a question of process, a management responsibility. They insisted on continuing with the same workforce that GM blamed for their quality problems. GM guys said, "It's your funeral." Toyota took the United Auto Workers laid off from the failed Fremont plant to Nagoya to show them how the line is run in a Toyota plant. One of Taiichi Ohno's innovations over what was considered to be assembly line best practices at the time was to install pull cords in easy reach of every workstation. One pull would set an amber light to call over a manager. If the problem couldn't be resolved in real time, a second pull of the cord stops the line. The ending cord is a story you've heard. It's a feedback mechanism which makes it explicit that quality is management's top priority, and that everyone, down to the guy sweeping the shop floor, has the authority to require a manager to come and observe some aspect of work in progress. Under the Toyota system, the manager's job is not so much to tell people what to do, but to respond to calls, to look at circumstances on the line in real time and make things right. Recognizing the value of favoring a feedback mechanism, Taiichi Ohno rejected the notion of fixed time as a regulator of the assembly line. In its place, he introduced a buffering system with a signaling mechanism which allowed for variable time at a workstation without adversely affecting the flow of the line. The signaling mechanism is called Kanban, which just means signal card. Kanban refers to a pull-based buffer system of workflow management regulated by a signaling system. Implementing real-time feedback using buffers in place of fixed time to regulate work laid the ground for shortening supply chains so that improvements identified from real-time feedback could be quickly incorporated into the supply chain, reducing the cost of having to scrap defective work already in inventory and increasing quality through continual improvement. This aspect of Taichi Ohno's contribution was known as just-in-time delivery. Now, Deming's books brought the revolutionary concept of just-in-time delivery and other Toyota production system innovations to the attention of American manufacturers. And his 1982 book, Quality, Productivity, and Competitive Position, provides a perspective on the state of what became known as lean theory after the big consulting groups got a hold of it. Recognition of Deming's role in sparking a revolution in manufacturing productivity was generally limited to management circles at a time when Ronald Reagan awarded him the National Medal of Technology. In Reagan's speech, he said, quote, "These are the dreamers, the builders, the men and women who are the heroes of the modern age." That was June 1987. The publicity generated by the award sparked a series of articles and interviews with Deming, then 87 years old. Seeing Reagan's speech, news editors from around the country asked, "Who is this Deming guy? Go get me an interview with him." His unpretentious optimism and vitality resonated with people working in spheres beyond manufacturing, including the rapidly evolving field of software engineering. The purpose of the Toyota production system practice of just-in-time delivery was mostly misunderstood by American bean counters as merely a technique to reduce inventory carrying costs. Software thought leaders recognized the essential value of establishing a systematic way of quickly capturing and correcting defects, and restated this quality assurance principle as a new standard of practice called continuous integration, popularized in 1999 by Kent Beck's Extreme Programming Explained. Finding and fixing defects in real time seems like common sense, but it brought radical improvement to the assembly line, and it brought about a transformation in how we build and deliver software. Identifying defects sooner saves a lot of time and money, learning from break-fix cycles, exploring root cause, taking action to prevent defects of the same type from recurring. But this kind of feedback mechanism can yield additional benefits, such as increased throughput and improved fitness of product. Think about what Sakashi Toyoda had said over a century ago. They do not have the expertise gained from the failures it took to produce the original. Our Kanban board and the delivery pipeline associated with it is where we can earn the expertise that over time sets us apart from our competitors. We develop the necessary expertise by learning through observation and experience. A delivery pipeline is essentially a set of policies, protocols, and heuristics, which generate signals that let you see what's going on in the process. Paying attention to this aspect of our Kanban boards and associated delivery pipelines is table stakes to higher order conversations. Now, the central problem of enterprise digital transformation initiatives as we find them today is that they practice what we might call greater Taylorism. Basically, that we're still working mostly out of the playbook of Frederick Winslow Taylor's principle of scientific management, where process engineering is treated as a problem of analysis, where the work is broken down into its component parts with attention to detail in the optimization of the parts, on the theory that if all the components of the process are optimized, then the whole must be as well. This is simply not true. The essential fact that is mostly overlooked is that software engineering and knowledge work in general is more a problem of synthesis than one of analysis. Analysis deals with the decomposition of the whole, followed by the intensive study and optimization of the parts. This kind of thinking brought revolutionary changes to machine tools and assembly line manufacturing, and is still an important part. It's still important in our line of work, but it's the comprehension of the system as a whole that will drive dramatic increases in productivity in the years ahead. Comprehension of the whole is called synthesis. We can't tell the story of productivity in knowledge work until we make synthesis an equal partner with analysis. Process engineering in a software shop is not the same as that of a machine shop. Knowledge work is a fundamentally different domain than the nuts and bolts of the mechanical world. Taylorism rules in the physical domain, but it breaks down in the face of the complexity and the ambiguity in the digital domain. The essential innovation to transcend Taylorism is systems thinking. So what do we mean by systems thinking? For this part, I'm going to largely paraphrase Russell Ackoff, who is a contemporary of Deming and a really awesome read, all of his material. So we can describe a system in terms of a couple of essential components. First is that a system is a whole that contains two or more parts, each of which can affect the properties or behaviors of the whole. For example, you're a system and a biological system called an organism, and you have parts like your heart, your stomach, your lungs, your pancreas, and so on, each of which affect your properties and your behaviors. The second requirement of the parts of the system is that none of them has an independent effect on the whole. How any part affects the whole depends on what the other parts are doing. So the way that your heart affects you depends on behaviors of the lungs and the brain and so on. The parts are all interconnected. Between any two parts of the system, there's a direct or an indirect path. And finally, if you group the parts of the system into subgroups, no matter how you subgroup them, each subgroup will have an effect on the properties and behaviors of the whole, and none will have an independent effect. Therefore, you can summarize those characteristics of a system into a simple statement. The system as a whole cannot be divided into independent parts. This has a number of consequences which are not apparent, but which are incredibly important. The first is the essential properties of any system derive out of how the parts interact, not how they act taken separately. And therefore, the defining properties of any system are the properties of the whole, which none of its parts have. Peter Drucker said that there's a big difference between doing things right and doing the right thing. You see, we're very much devoted to doing the wrong thing right. That's very unfortunate because the righter you do the wrong thing, the wronger you become. When you do the right thing wrong, when detected, it allows us to improve. So the distinction is absolutely critical. Agile transformation is an industry that's simply drowning in efficiency in pursuit of the wrong ends. So we need to limit ourselves to a conception of the process engineering. So long as we limit ourselves to a conception of process engineering as a form of greater Taylorism, there isn't really any hope of aligning process metrics and performance metrics with the profit and loss. When we begin to think in terms of systems and define our systems in terms of services, then we'll be in a position to begin to tell the story of productivity in unambiguous terms. So time is our most valuable asset, and I thank you so much for devoting a bit of yours to this humble account. I realize it's just scratching the surface on a broad topic, but I hope that you found something of inspiration of it in your own journey. We can conclude the formal presentation here and move into questions. And let's see how this works. I can start sort of as you think of what kind of the questions you might want to ask. I'll give you a moment on that, and I'm going to